So good afternoon, everybody. Welcome to our SUSECon session about 10 years SAP HANA availability and what comes next. My name is Fabian Herschel. I'm working for SUSE for a long time and also in the SAP Linux labs. And my, I would say passion and responsibility as SAP workloads in HA clusters on SUSE.
Yeah, my name is Lars Pinner. I'm working with Fabian in the SAP Linux lab on the same topic. And today we want to present you more about what comes next. And we have organized the overall session into more or less 4 sections. First, we would like to give you an overview over the solution, what we have prepared for you. Then we will look into the details, what is new with this new HA solution for SAP HANA. And among this session, later, we will give you inside a demo. We have recorded 2 HA cases. The first example is a classical cluster, how it runs today, how it reacts on a failure, and the second one is a new cluster, how that reacts, and then you might see the difference and one of the advantages. And finally, of course, we will give wrap up a summary what you have to take with. So if you are tired, you can sleep until the last session sample, and you will get everything what you want in 3 minutes or so. If you are more interested, then stay live or stay awake, and you can see something. So what's included with the HA package we call SAP HANA SRNG, but for now, the use cases we are covering with our HA cluster for SAP HANA databases on Linux is quite a lot. We are covering scale up and scale out use cases. That means scale up is a HANA database where the whole database runs on one server or in one virtual machine. And on the other hand, scale out means the database is too large or has other restrictions or other requirements, so it does not run on one machine or one virtual machine, but it runs distributed across 2, 3, or even more virtual machines. And in both cases, the basic HA concept of SAP HANA is something called system replication. That means we have 2 databases running. One is a primary database, which does all the transactions on behalf of the application, and the other one is a secondary database, and both databases are connected by system replication, and every transaction which is booked into the primary database goes to the secondary, is booked there as well. And the idea is if the primary database fails, you can switch over to the secondary becomes primary, and business goes on. This is the idea. And to make this happen, we need some piece of software from the SUSE side. That is our HA solution. And if you're looking in more detail into these setups, we have different use cases. And the basic message here is most use cases you can set up with HANA system replication are supported with our HA scenario as well. We have documented all supported use cases. We have documented what the special things is, how it has to be set up. And if you do not find something you want to implement among our documentation, do not hesitate, contact SUSE, contact your partner, and we will see what we can do for you. And of course, this list of solutions is growing. We are working on improvements, and for the future, improvements will go into the new solution we are talking today. And basically, at the moment, is kind of we supporting the same setups with the old and with the new. So, 10 years SAP HANA system application, long time. It was a long way from the very first beginning. And question is how or why should we change this? It's a proven solution. It's kind of stable. It's widely used. Why do we change? So there are several reasons. So 10 years ago, there were some paradigms. So HANA was mostly appliance. There were some restrictions. There was only very limited scenarios supported from the SAP HANA side. And so the very first implementation was focusing on that requirements. and these requirements changed over time. There is now a lot of different details like multi-target replication, or even scale-out was not available in the very beginning. All this has been built in later on. Another important change is in the very beginning, almost all HANA databases were installed on-premise and even on bare metal. And nowadays, good fraction of databases is installed virtualized. Almost all installations are virtualized, and customers now are going into cloud. And this has implications for the cluster as well. So the behavior of the infrastructure is an important thing, and the cluster, and the resource agents need to address this. There are several other details. So it was from the requirements we got today and from our experience, a good point to start thinking about how to improve the solution. And these considerations led to a redesign of the solution, and the outcome is this new package. This is a so-called SAP HANA SAP package, and this is, I think, something you can speak on.
Yeah, thank you, Lars. So first of all, we decided that we have now in the future one common package for scale up and scale out. In the past, we developed that separately because scale out, the solution came very bit later than the first one, and then we had a lot of customers already in production. And the changes in the code to come from a one-to-one node synchronization to multi-node synchronization were that big that we decided this could maybe also be dangerous for customers if we would do that in one code. So we now did take a second round and said, okay, now we have a chance to make it on our labs and to test it carefully. So in future, you just need to install the SAP HANA ANG package, and then you can do scale up or scale out. You could even theoretically switch from a scale up to a scale out cluster with the same software installed. There are 3 common resource agents for both big scenario groups, named the SAP HANA controller. So you may, if you have scale up, your name of resource agent is SAP HANA. It's now named like in the scale out, because this name a bit better addresses what exactly the resource agent is doing. There's also the SAP HANA topology resource agent. And the third one is SAP HANA file system, where we come a bit later about. And we did separated the code. We did find out that a lot of code things in SAP HANA controller and SAP HANA topology are the same. So we decided to do something like bash libraries, which have been loaded from all of those resource agents. So we have something like a common case, and if one resource agent is fixed, then all other resource agents are also fixed. And we decided that we want a bit to decouple the dependencies of a resource agent. So in the past, SAP HANA topology got a lot of values into the cluster database, and SAP HANA controller only consumed that. But this has some problems once customers did not follow our maintenance procedures. So we decided how could we improve that, and so we did code a bit differently to have a resource agent a bit more independent. Now it's
Thank you. Yep. Benefits for customers. So it's not only about refactoring the code and making our life easier. The basic idea was indeed to make your life easier. And Fabian already mentioned some aspects. Now we can address better maintenance procedures than we did in the past. We have improved monitoring intervals. That means the more often a resource agent needs to monitor something, the better is the chance to fail on something, and the higher is the load on the database. We were able to improve that. Lots of minor details have been improved, and now we have a foundation for further improvements in the future as well. If you have scale up and scale out, One thing is that you now have to install only one package. In the past, there were two different packages. Fabian already mentioned you have two slightly different kinds of configuration. All this is unified now for scale up and scale out. And there is a very big improvement already. It's a new file system, resource agent. It's called HANA File System File Source Agent. And the issue we addressing here is in the past, the database were running on-premise with stable infrastructure. Particularly the classical fiber channel-based SAN storage is solid. If something does not fail, then it is a storage usually. This was the past. Nowadays, we are running not only in virtualization, we are running in public cloud. And public cloud has different SLAs for storage than you have on-premise. And we have learned from our partners and customers that we have to handle sporadic intermittent file system outages. And classical setup was not very well prepared for this. HANA itself does not care about it. It does not report an error. Even worse, the binaries we need to monitor the HANA are stored on a file system which is not available from time to time. So the cluster cannot even monitor the status of the database in that situation. And therefore, we needed to solve this by monitoring the file system on its own. So in the past, we did not care for the file system. We just monitored the HANA. Nowadays, we need to monitor not only the important HANA, we also need to monitor file systems. And this file system monitoring has to be combined with the HANA monitoring. Any action that should be taken on the file system has to be first check if this action makes sense in the context of the HANA status. So if the HANA is not synchronized between the two sides, it's not a good idea to do a takeover, because then you go from a consistent, not working database into an inconsistent but working database, which is the worst case. And to avoid this, the file system resource agents need to understand the HANA workload. And this is the one thing we already ship with this new SAP HANA SAP package, which makes already several customers asking for when can we use this in production. Yeah, and now, after a short overview, we go into lots of boring details, and then we come to the demo.
So thank you, Lars. So here on the left side, you see just the names where the resource agents and the libraries are stored to. So this is something you might like to know when you are doing software checks or whatever. So we have these three resource agents. Two of them are new if you are thinking about scale up. It's the SAP HANA controller renamed. The SAP HANA file system Lars already spoke about, and we will focus a bit later on. And the SAP HANA topology resource agent, which is already well known to those who are using this solution. And then we have split up the resource agent. So these are only very tiny bash programs into libraries. So the real working is being done in this resource agent libraries, and those could be also loaded in future if we need to enhance our solution by other resource agents. One thing maybe also important is that we switched from standard of a cluster OCFs 1.0 to 1.1, and there are some special new things the pacemaker OCF standard OCF 1.1 gives us. One of this is that you can switch from the master-slave resource agent, which is a bit bad naming, to the promotable clone, and you completely define it in a different way. So it's a more modern way in pacemaker how to tell the cluster what you want to achieve with this resource. So if we look on the SAP HANA topology resource agent here at the top, you see that one important thing for you is that we increase the interval. So in the past, we had a very short interval for SAP HANA topology, because it was needed that this one has all in place when SAP HANA resource agent or SAP HANA control agent begins to run. And so we had sometimes a bit a race on HANA, so, or at least a big pressure on HANA. I don't know why a fast database gets pressure if I ask it simple questions, but it is that way. So we decided to have, I think, a 5 times slower interval here, and to do more things in the SAP HANA controller resource agent to get independent, as we already discussed. The most important thing here for the SAP HANA controller is that it is now defined as a promotable clone following the new standard, as already said. And yeah, with that we can go to the details of some resource agents, also as SAP HANA file system resource agent. Here on the top you see such a definition. So you just define for which SID instance it should work on, and it does not control the file system, so it neither mounts or unmounted, but it checks the availability and combines this result with the system resource agent status, because nothing gets better if this file system is frozen but the secondary is not in place, because we just want to make the takeover faster if something hangs. Think about, as Lars already told, that here these file systems, SAP HANA data, log or shared, even the worst one would be the last, because there are the binaries. So if in modern infrastructures, like if you are in cloud, have their own SLAs for your storage systems, and they are different than you are used on your on-prem situations, then it could happen that exactly these file systems are out of order for some time. And what happens if a resource agent or disk is just frozen and you want to start a binary from that, which tells you if a database is up or down? So then the cluster gets unhealthy and could not decide anymore. The pacemaker cluster needs to know that a resource agent is really down once it would make a takeover, because a resource in a special status, like a primary, should only be run once in the cluster. So this resource agent then gives us a chance to solve that, because it marks if a primary has a hanging file system which is been defined by you, and checks if a system replication is okay. If that's the case, then the fastest way is to go to the secondary site. And so this one gives you a better SLA. And this will also be shown in our demo later on. So, as we already said, scale out, scale up is being combined in one package. This also means that the attributes which are being written by the resource agent and could be shown by the show attribute command line tool are now looking like you are knowing it already from the scale out thing. And this is also why you can grow from scale up now to scale out without breaking your cluster. You just need to follow some maintenance procedures if you increase the cluster. So new for scale up clusters would be that you here have now a site-orientated table. So like in scale out, all attributes which are site effective are now printed to or stored in this site table. And one thing is we named it a bit more better, that it's more clear that they belong together. So this is the system replication status written by the hook, and the SRPOL attribute is the status written by the resource agent by asking the HANA regularly during the monitor roles. In the past, maybe you have seen that those attributes have been written to different tables, and we improve that for the admin experience as well as for a bit more clear on this here. So here's how it looks, just a short look into inside the cluster, how it would look like in the cluster configuration if you would open it Because we have moved the attributes, one thing is we discuss later is how we now migrate. Once we would like to migrate from classic to ANG. And with that, I again hand over to Lars.
Yeah, thank you. So one aspect of this HA clusters are the resource agent we have looked into, and the other aspect is the hooks. Resource agent are controlled by the cluster, running on a cluster schedule. Hook scripts are controlled by HANA. They are called by HANA on events, so it's asynchronous. And for some reasons, we need at least one of them. We need at least the former SAP HANA SR Python hook script. And now this one is called SUS HANA SR Python hook script. Why that? You can see it from this table, because all the others already have been called SUS something from the very beginning. Only the SAP HANA SR hook script was called SAP HANA SR. Reason is the SAP HANA SR Python was the very first one we introduced 8 years ago. At that point in time, it was not clear that we need more of them than one. And at that point in time, it was not clear that HANA internal trace files are trunking the name of the resource agent to like 10 or 12 characters. And if you have something SAP HANA SR detail like whatsoever, then you will see only SAP HANA SR and nothing else. So we decided to clean up the naming, and now every hook script is called with SOS and then a special purpose of the hook. And this is the only reason why it has been renamed. Yeah. And now Fabian already has mentioned upgrade. Upgrade from a classical SAP HANA SR cluster, which has been the best of ever until now. And now we go to the SAP HANA SR ANG, which will be the best of ever from now on until guess. Yeah, it's doable. It's not exactly trivial because we have to change inside the cluster the resource configuration slightly. We have to change almost all of the attributes, and outside the cluster we have to change the HRDR provider hook scripts which are configured in the HANA global INI and loaded into HANA. So you have to do several steps. For example, you cannot remove the RPM before you have upgraded the HANA global INI, because HANA will refuse to unload the old hook script if the file on the disk already has been gone because the RPM has been removed. So we have defined a specific upgrade procedure. We have written a manual page. The older ones among you may remember this manual pages. It's something you can print out and read, and you can cite marks and so. And by the way, you can do it as PDF as well. We have described a detailed procedure how to do the upgrade, how to check the prerequisites, which steps to do in which order, where to look for, and so on, some example commands. But this is only an outlined document because customer situation is sometimes different, some expectations are different whatsoever. But anyway, we also have prepared a script which can be run on a HANA cluster, and the script collects all information about SID, instance number, your resource configuration, and so on. And then it puts together a set of commands with all parameters for your specific cluster. And if you then check this set of commands, try out if it works, then you have a procedure with like 120 or so commands you can run, and then your cluster is migrated from the old classical SAP HANA SR package to the new SAP HANA SR ANG package and looks like freshly installed. Of course, what you can do as well is you can just remove the old configuration and then use your automated deployment to deploy the new one. It's possible as well. The trick is always during the remove, how to remove the resource agent while keeping HANA running. This is the one interesting point. And because this is one interesting point, I have printed out here what this demo script would provide an information so you can do this upgrade without HANA downtime. Of course, it's the cluster goes to some fragile states. You should not do it under high load. If you do the quarterly business update on your database, you should not run the upgrade. But if you can find something in the midnight or Easter or whatsoever where you do not have too much stress on the database, you can do the upgrade online. This is very important. By the way, we have prepared a blog article about this. And if you feel unsure, you can contact us. Our services should be able to help you with this as well. So now it's demo time. We have prepared 2 videos. The first one shows a file system outage on an old cluster. So this is what you have to expect if you run with your running cluster today in this problem. The cluster would take 35 minutes to resolve the situation because of the timeouts we need to wait to find out everything really is broken without having the binaries. Everything runs into timeout, then takeover takes place, and with a standard configuration that takes around 35 minutes. And normally this is not what customers want to have, or some customers can tolerate, but we have learned from customers, many customers do not want to tolerate this 35 minutes outage. The cluster is able to come out, it works, everything is fine, but it takes 35 minutes. We do not want you to watch this 35 minutes video the full time, so we have done a shortcut in the middle, but the basic I think we can show to you.
Should I start?
Yeah, please start.
So it's running.
So what do we see here? We see here the running cluster. We have prepared a short script that catches all the information. On the top half, you see the usual cluster state. CRM1 shows all the resources, the cluster nodes. And then below, we have the old style SAP HANA as a show attribute with the details on the HANA database with the system replication. And at the very end, very important, cluster state idle. Only if the cluster is idle, you can expect the information to be valid, and you are allowed to type in commands. If the cluster is not idle, the status you are seeing here is not valid because the cluster is doing something in the background. Fortunately, you can ask the cluster whether it is idle or not. We have to wait a minute. I'm not perfectly prepared on the runtime of the demo. Yeah, you can see everything is fine. System application is in sync, so no reason to change something. Unfortunately, sometimes something happens. By the way, upper right corner, we have a real-time clock. You can see we've recorded this 10:30. It was either in the morning or in the evening, don't know. Later on, we will see a counter which counts down for the downtime. So what do we know? We see the configured HANA resources. This is the standard default HANA resource configuration. Nothing is special. We have all the timeouts. So for the monitor, we have a timeout of 700 seconds. If the monitor is not able to get the status information, it has to wait 700 seconds because before it comes back to the cluster and says something is broken. Then we have the stop timeout. Stop timeout here, we already have shortened it a little bit to half an hour. So if the resource is not stopping, at the very end, the cluster will kill the node. But this is not a very friendly decision, so we want to give the HANA amount of time. Years ago, we decided together with SAP the default should be 1 hour, but we learned that most customers do not want the cluster to wait for 1 hour, so we already reduced the time here. But this is something the cluster has to wait later on as well. The tricky thing here for the cluster is the resource, the file system is blocked, not the node is dead and not the HANA is dead. If node would be dead, the cluster would react within 5 minutes. If the cluster could find out HANA is dead, it would react within 5 minutes. But if the file system is dead, it's a different story. Now we've tried to find out where the HANA primary is running. So you can do it by script. So if you want to do some automation or some whatsoever monitoring, you can use scripts like that. we see the node named Watzmann 1 is the primary. By the way, Watzmann is a mountain in the Bavarian Alps for the Berliners among us. So what we do now is we try to freeze the file system to simulate the failure. It's done with this command. So if you want to do QA or some testing, you can do it with your cluster as well. Obviously,
And
better
don't do it in a production.
Yeah, only once in the production. So we do it. Okay, it was in the morning, 10 o'clock in the morning. This is 24-hour format.
And you see the downtime counter at the upper right already running?
No SLA. No, we are running against SLA. So, okay.
Yeah. Thank you. So.
Yeah. After a while, we will see it gets boring. Normally, you should see the clock, the counter running up to 35 minutes, but
we did cut it for your convenience.
But what we want to show is, at the moment, the cluster has not even detected the failure. Hopefully, the window will shrink so we can see the cluster detecting the failure.
You have your while loop.
Exactly. Now we are watching. The one thing we want to do now is we want to catch the time when the database is back. To get the exact time, we have this short script fragment. We can watch to the wall clock, but we did it with a script this time. So, and now, as you can see, already 1 minute has passed, but the cluster did not even notice the failure because of the monitor intervals. The monitor has to run.
We did have the first cut to jump a bit to the monitor error.
Yeah, the idea was now the 5 minute, we have assumed it is 5 minute SLA. The 5 minutes are already over now with this setup, as expected. And so we wanted to highlight this. So the cluster has detected the failure. So we have done something in the middle, maybe gone to the kitchen, a coffee. We have cut out 30 minutes. So cluster has sitting around for 34 minutes now without reacting because of all the timeouts and the nature of the failure. This one specific failure is the ugly one. So now the cluster starts repairing the situation. Now it goes very fast, but we had to wait this 30 minutes.
So now the cluster tries to have stopped the HANA, and this failed. So now you are in the situation that the Watzmann 1 is fenced, and the cluster now could react on that. It just needs to wait till Watzmann is guaranteed to be down.
Exactly.
So this depends a bit on your infrastructure, and we have here assumed about that token time could be up to 30 seconds.
Yep.
Now it's defined as offline.
Yep. And now the cluster can take over. Now it's safe to do a takeover. And this again takes some time. It depends now on the HANA. Everything we have seen until now depends mostly on the cluster and the infrastructure. And now the takeover depends on the HANA. So it's still not repaired, but at least the cluster is working. So you can see the two capital T's. That means the cluster now is doing the takeover. If you want to monitor your cluster in depth, or if you want to do really detailed testing, I recommend you to make yourself familiar with the SAP HANA Session attribute. Everything you need is displayed by this tool. It's very powerful. And now the script got the status. Now we see the role of the secondary HANA is primary, and the status, landscape status is 4. Landscape status 4, role primary, that means now HANA is running on the other side. Now business can continue to work on the other side, but it has taken that time, or even longer, because we fooled you by...
So in the downtime clock ended up in 37
minutes, exactly.
minutes. But now we are looking how Angie is doing it and what the SAP HANA file system resource agent could do for you. You'll see, first of all, as we have seen on the slides, that the same cluster, but configured for Angie with the Angie software, has a bit more lighted attribute tables, has those side tables here on this, which are also capable to catch scale out clusters. So you have the same view for both worlds in the future. Once you start with SAP HANA Angie, we have the same setup. We have a cream colored clock at the right, which will change the color. And we have this admin console where we now do nearly the same. First, we look for the SAP HANA controller and the SAP HANA file system resource agent. So you can see that this file systems resource agent just also gets the SID and the instance number, so it's quite plain. And it could then check the file system where HANA typically is installed. You have the SAP HANA controller, which is being configured as a promotable clone. And as we did on the classic, we will then go to showing where's the primary, where's the secondary, and so on. Maybe one word, we did not change the timing, as you can see, so we used also a stop timeout of half an hour here in this cluster, so we did not fool you. And the show attribute script also says, we begin again on Watsman 01, so same direction, we take over from first node to the second node. And in the same way, we are freezing the complete file system /HANA. And if the admin would now enter, you would see that the downtime counter also begins here. Still, the clock is green. And as we have assumed, the SLA is 5 minutes. Hopefully, it will stay on green. So with a while loop, we again check if we could detect from the attribute values that the Watsman 02 would be the primary. And now we are checking what the cluster is doing. We will also jump a bit because also 5 minutes would be maybe too long just to wait for everything. You have now seen that we jumped a bit forward. And we'll do a second jump. So it depends a bit. Now the file system resource agent, not the HANA one, because this one is hanging. The file system resource agent did detect there is an error, and it did also check that the system replication was in sync, and then also triggers a stop error. And this is by intention, because this sequence, monitor error, stop error, gives the pacemaker the chance to rapidly decide that this node is to be fenced and that the cluster then is again back into reaction. So you see, after 2 minutes, the cluster is already doing what we had at 32 minutes in the other situation, where we did not have this component of checking infrastructure errors. And so the cluster is already working on it. Watsman 02 is also, because it's a VM, it's very fast booting, it's already waiting for going into the cluster, but it has to wait till the cluster is a bit in a different state. As Lars already said, always also watch the cluster status here. This is still in transition engine, so it's still processing. And you see already over there that the attributes for the takeover shows up that currently already the takeover of the SAP HANA is working. So we are at 3 minutes and it's already in process. And now only it counts how long this HANA will take for the takeover. And then we are back on production and your HANA is back for your client access. So let's wait a bit till the takeover is done. Thank you. And you see now that the dual T marks here in the attributes are gone. So the process of the takeover has been done just in time. The admin has opened his window again. And the downtime counter ends up with 4 minutes and 70 seconds. So you have seen now we are back with the cream colored, and it was much faster. And the difference is that the infrastructure are changing if you go from premise to systems where you define things in software, and if those components goes down, the cluster now needs to do new things. So let us now change to the
back to slides.
Slide.
Okay, so hopefully you get an idea what is new and what is better. Information, where can you find further information? We have, of course, the manual pages with the new package, not only for the new solution, but also for the upgrade procedure to manual pages. The SAP HANA is an upgrade to ANG, and the SAP HANA is an upgrade to ANG demo manual page. We will upgrade our supported scenarios guide because we want to inform you that all the scenarios we currently are supporting with a classical package will be supported with a SAP HANA as an ANG package as well. We have a setup guide already published for scale-up performance optimized, so you can start as soon as the package is publicly supported. And we already have also prepared a blog on upgrading, and of course we have the recording of today's session. So what to take with you? We have a dozen of supported HA scenarios with the old setup. We will have the same basically with the new setup. The setup guides are a little bit behind. SAP HANA SANG is aimed to ensure HA for HANA on Linux for the next decade until we are retiring. And the first improvement is this new file system resource agent. We already have some more improvements to decrease downtime on flaky infrastructure even further. We cannot talk on this today, but maybe in a few weeks, definitely next year, SUSECON, you will learn about more. We highly appreciate your feedback. If you want to do a POC, go ahead. Maybe you want to hurry because SAP HANA SANG will be fully supported for production already with SP6, so in a few weeks from now. And from then on, it will be supported in SP6, SP5, and SP4. The old solution will be still supported for the lifetime of /15, but we want to encourage you to use SAP HANA SANG wherever possible. So for new deployments, no question. For upgrading old systems, yes, of course. And one final statement, the ANG is an acronym for Advanced Next Generation Interface, but to get more public traction, we might want to decide to name it Artificial Next Generation Intelligence, because I've been told this is the next big thing we want to do. Yeah, thank you.